Halo, apa kabar semuanya? Welcome back to the course that talks about basic pattern for data analytics, stock prediction. In this case, we are going to try to use a glimpse of machine learning in order to predict stock price. Alright, so now inside this stock price, what we are going to do is that we are going to build three models and evaluate them. The three models are using simple linear analysis, quadratic linear analysis, and finally k-means neighbors. But first, before doing that, let's extract the kinds of information that we need from our dataset and apple stocks. Okay? So first of all, let's review the data that we have. So we have open, high, low, close, volume, negative, close, and the dates of the apple stock. And afterwards, we want to make it into this table. So how do we do that? Well, very simple put is that we just extract it from adjective, close, and volume. Okay, so for this sector of cleaning up and showing this to you, there's quite a lot of things to type, so it will take time. But feel free to just pause and just copy paste this, type it by yourself so that you kind of understand how the procedure works, how the formula works. So all of these are just mathematical calculations, okay? But moving on is that we need the HL percentage. So first HL percentage is just high minus low divided by close. So the range of the high and low and then divided by close. So what's the ratio there? Alright, so that's high low percentage. And the fourth thing that we want to have is the percentage change. So you can use this or you can use percentage change as well, but divided by the offer price. So it's the same thing, either way you choose, but in the end, you want to create this model, right? And before we do linear analysis on this, we need to clean this up first. So I'm not going to type this one by one, it will take time, but I'm going to explain to you what happened one by one, alright? And then you can type it yourself or just copy paste. Alright, so first of all is that you want to make sure that you import these libraries. These are very important library for data analysis purposes. For you to tweak the data in a way that you can take some for testing your models, and you can pick some and transform them in a way that your model can comprehend. So first of all, you want to make sure there's no missing value. And usually is that if there's a missing value, then you want to fill it in with minus 99999. Why minus 999? Because through the models of sklearn, which is the another pattern library, is that minus 999 is considered as a outlier of or null value, so it would not be comprehended. It will still be there in data, but it will not be calculated or be left out by the linear analysis. Alright? And we don't want to lose down the whole row because that means that you don't only just like minus 999 of that, but you actually delete the whole row. If you don't want to do that, you lose information. That's why we replace it with a number instead. Alright? Then afterwards, we want to separate 1% of the data to forecast. So we want to forecast the last data. So what we do is that based on we want to find out the number of 1% of our data. So our data has 1771. So what's 1% of that? It will be 17. So you will take out 17 data and put the number in the forecast out. Okay. And afterwards, we take the forecast column. So we want to forecast adjective close here. So we want to separate from the other. So we have two tables now. So one table for the predictors, like the volume, HL percentage change. So there are three rows, three columns, and the other one, the one other table, so it's a bit confusing left and right here, is for the label, which is for the adjective close. So we want to predict adjective close by using the other table. We don't know this, but we know this. Alright? Okay. And afterwards, we want to pre-process scale age. So what does it mean by pre-process? Pre-process meaning that we want to make this on the same playing ground. If you see here, volume is around 100 million, and so but agile percentage maximum is only like 2 or 3. So those are very different scale. So what we want to do is that we want to make sure that they are on the same playing ground by the scale of 0 to 1 comparing to the others. So what we can do with that is that there are many different ways. We can like square root them. We can like do a logarithmic algorithm on that. But either way, we want to make sure that they are on the same scale. And Python, apparently they already have library that does it for you. It's called pre-processing library. That's why we import it here. sklearn is, by the way, a library that talks about machine learning. So all the models generation, statistical creations to predict future data based on historical data is all handled by the sklearn library. It's quite extensive libraries. There are quite a lot of things, quite a lot of customization available. You can just Google it sklearn here. Just Google it and then you can see these websites. So just give it a brief scroll through, see what you can do, classification, regression, clustering, and so on. And try to experiment. Alright? Okay, moving on is that we want to take out the X lately. So X lately is the dates that are later, so it means that the 18 latest data that we have discussed before. Then we want to take out these 18 data from the table. So we want to take out because why? We want to forecast these 18 data. Alright? And finally, we take out the training data sets, and so on. Alright? Then finally, there's one more thing that's quite important for sklearn is to evaluate the model. So to evaluate the model, you need data, the trained data that talks about predictors. So predictors are the variables that can help determine. So based on the volumes, based on the actual percentage change, what would be the close price? Okay, adjusted close price. So based on known adjusted close price. So the next time we are given a certain data sets that talks about these predictors, then what would be the forecasted? It might be a bit confusing for now, but basically those that we don't know the adjusted price is the test, but those that we know the adjusted price is the train. So the train is used to train the model, the test is used to evaluate the model. Okay, it will be clear later on. So how to build a model? Very simple put is that we need to just instantiate a model. We create a model object and then we train them using the train datasets. So how we could do that is very simple. So we do from sklearn import, and here I have a linear model from sklearn linear model import regression linear regression. Okay. And from here, then what we want to do is that we want to build a classifier. So CLL frag regression equals to, and I can just equals to linear regression. And from here we can see what is there, and I can put n jobs -1. So either way it's the same, and jobs can be whatever. You can even put it as the default, but for now I put it in jobs equals to -1. Alright. Then afterwards what I do is that I want to fit this data using the training set. So here run fit x train and y train. Okay. So x train is the 3 predictors, y train is the adjusted close that is known. Right? So that's it. Basically, I already built a simple linear model, and I run it, and it gives me linear regression. So this printout says that I managed to make this model. Alright, then I can test this model. Simply put, it's just confidence reg equals to CLL reg score. So I can score them. As y as so given a test data set, what will be the y data set? I can print them out. The regression confidence is confidence crack. That's it. And if you see here, you see that 0.96, meaning that, wow, the confidence is very good. It's 96% get it correct with an unknown data set at the time. Correct means that it's quite close, okay? However, the thing is that it doesn't justify that it is a good model, because it just says that, oh, the stocks resembles a linear model. So, which is true, the stocks is going rising up, but it's just like very jugular, and you don't know it's trend up and trend down, but most likely trends are going up, as we have charted before. So it's still not that comprehensive enough, but how we can make it comprehensive is by making a forecast. The forecast set equals to, then we forecast it, so CLFreg dot predict. And what do you want to predict? We want to predict the x. So x 18. Remember that we get the 18 data, so we want to take this 18 data out. Okay. So I run this, I can actually print this out also. As set, and you see that there is a prediction here for the next 18 days. But this is not useful until we plot it. So let's plot it. So I have this plotting here. So basically I'm creating a time log. I populate the forecast. Okay. And one thing I forgot to make is the forecast. So DataFrame forecast equals to NP. Let's try. Okay, so I just run this. Oops, it's not empty. Empty dot, oh, none. Sometimes I get one. Okay, there you go. So basically I want a placeholder of forecast that doesn't have any data yet. Alright, then afterwards I plot them out. So I create a time log to plot them out, calculate the forecast set, and I finally do it with the aggregate first and forecast. And in the end, this is what I get. So I get the forecast is actually here. So the next 18 days, the forecast will be going down and going up again. So that is the kind of things that you can do with it. And of course, this is not necessarily meant to be a very accurate model for you to use stock market value straight away, but it gives you a sense on how you can analyze stocks. And of course, it can be combined together with quantitative quants, quantitative finance, kind of like literature. You can actually get a new sourcing and new sentimental analysis to complement your analysis. Put sentimental analysis values and then get the final results. And you can put HPI and so on. So I might be doing this for the advanced course in this playlist. Okay, and you can do the same thing with, you can make different models. I'll just do it very quickly. Alright. So I just uncomment this one by one, and uncomment this, uncomment this. Then if I run it, then basically I get 4 different models, and it's cool. You can just do different models and see which one that gives you the best result. And you can see how strong the model is given the data. And you can use the strongest data, find it is the simple linear regression, and just plot it out, predicting. So that's all about the financial stocks market prediction. I might be doing the advanced, but for now, with that, I would like to say thank you and see you next time for the basic pattern for data analytics, talking about HR manager and how you can predict employee retentions. With that, I would like to say goodbye. Terima kasih telah mendengarkan saya. Thank you for listening to me, and see you for the next lesson. Bye bye.